Right. Good afternoon, good evening, ladies and gentlemen. Mr. Harper said, raised his hand, and then he said, sorry, sir, my phone slipped out of my hand. That's okay. You can raise your hand. You can even ask really nicely, and you can say something. That's perfectly okay. So welcome, everybody. Obviously, yes, today is a Monday class schedule. So that means that we've got a lecture starting now at 5:10, and it will go on until 5 minutes to 6. Yesterday, we started and we introduced the principles of pointers to you. And let me just quickly do a recap of what we discussed. So I'm going to share. Yeah, let's share just the window. That's fine. Okay, let's just wait for it until it's shared. Right, so what you can see, it's one of my favorite teaching tools. We said that, remember, we've got a bunch of data types like ints and characters and doubles, etc., etc. But we also get a special data type called a pointer data type. Now, there isn't something called pointer, so you don't type in pointer, and that's now suddenly a data type. Instead, what we do, we go to a data type that we already have, like an int, and then we put the little star character into it, and that immediately changes that data type into a pointer data type. Now, with any data type, you obviously still have to give it some kind of variable declaration. So in this case, let's call it PTR value, and just like that. Now, what happens as soon as you type this in its code, what happens is that your computer goes into your computer and it allocates some memory, that's what this little box means, for that specific pointer. Okay, but what does this box contain? We said that a character data type can store a character, an integer data type can store an integer, a double data type can store a double value. So what does a pointer data type store inside this box? Well, a pointer data type stores an address. And we've seen that if you just declared a variable, we don't really know what's the value inside this box. So that is still the truth here. One way in which we can initialize this box so that it actually points to a valid location is to use the new keyword. So we can go to our variable now. We can say pointer value, you are now equal to a new integer box that you're going to point to. Why must it be integer? Because that's how we declared the pointer. We said this pointer type, that's what int star means. It is still a pointer type, but this pointer type will point to integers. Now, as soon as you do that, then somewhere else in memory, an integer box gets created, and inside my original pointer variable, the address of my new integer box is written. Now, the address of this new little box is F8. So I'm just going to say F8. There we go. It is in there. And because it's now initialized, it is a yellow color. And I said that it's easier if we can also just draw a little arrow there, because that helps us to visualize that it's now pointing to that location. And if I want to give a value to this new variable, then I do this. You dereference it by the star again. The value of PTR val is, let's say, 9. And as soon as you do that, obviously with a semicolon, as soon as you do that, it says, hey, this box that you're pointing to must now get a value of 9. And obviously when I output it, same syntax applies, output that value that pointer val is pointing to. And then it will output the value of 9. Okay, that's what we discussed yesterday. I'm not going to go through all of this again today. What I want to do is I'm going to continue, and the reason why we use pointers, one of the first reasons why we use pointers in Computer Science 1 is for the using dynamic variables, or sorry, dynamic arrays. Now, let me just see, there is a question from someone. Just give me a sec. No, it's not a repeat of yesterday's lecture. So the question is this a repeat of yesterday's lecture? No. If you followed, you'll see that I just want to quickly recap, just so that everybody's on the same page. Right, let's move on. Okay, so where do we use these pointers? I said just now, we use this in dynamic arrays. Why do we use dynamic arrays? Well, let's consider quickly the following problem. Let me just share my screen. I'm going to share code blocks. Boom, 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 boom. There we go. Just wait for it. Okay, good. You guys can see code blocks there. So what I have at the moment is a very basic application, really, really basic, with stuff that you should already be aware of. I declared a const int that says I'm going to write a program that will accept 10 inputs for users. And I've declared a variable. This is an array variable called array nums. Will store integers in there, and I'm going to store 10 items in there. And this is how we declared a fixed size array. The thing with these fixed sized arrays is this 10 is specified or given by the programmer, and that can be problematic because, as I've mentioned this yesterday as well, this is great for maybe this year's class, but what about next year's class? How do I get a class list of numbers that is, I don't have to go and modify the program every year when I want to use this? Can't I ask the user something like this, int, let's say int count, and then I will maybe do a cout, how many students do you have? Right, and then we will maybe read it into int count. All right, and as soon as I do that, then int count obviously is now modified, but I cannot modify this const variable to int count now, because that is now not how fixed size variables work. In fact, if I compile this, let's quickly just see what the error is. Now, obviously, it doesn't want to give the actual error, but basically, that you cannot do this. You cannot, during the program running, go and modify the size of this. As soon as we start using this program, it will start crashing. That is something which you guys have to realize. It is different. The way that it was declared, think of it this way: this is a constant size. You can't modify a const at all during the running of the program, so it has to stay const. So how do we declare a dynamic one-dimensional array? Now let's go back to my Excel so that I can demonstrate to you what's going to happen when we declare this in our computers, and then we'll come back to code blocks. Okay, so I'm just going to get rid of everything that I've done so far on the screen. Okay, that's what I wanted. Oh man. Okay, and I want to get rid of that. And I want to get rid of all of those things. So we've got a clean slate kind of thing happening here. Okay, right. So what we're going to do is we're going to first declare again a pointer data type. So we're going to say I'm going to have a pointer that points to an integer. And this time I'm going to say this is array nums. Now, as soon as I do that, we've already seen a little memory area gets created. So inside memory, boom, I get a memory block created, boom, and that is now inside the block. What is inside this block? Well, it is a pointer type, but this pointer can point anywhere. It can actually point there. We don't know what that value is. So how do I give it a value again? Remember, we said that if I want to give it a value so that it actually points to a valid location, we use the new keyword. So I can say new int, but hold on. Now I can actually take it a bit further. Can't I tell it to point to a number of integers instead of just one integer? And that's what I want to actually demonstrate now. So let's just give me a sec. Sorry, I'm just checking up something quickly here. Sorry about this lull. Yeah, I just wanted to make sure about the bracket that I'm going to have to use. So you have to use the square brackets. And now, let's say, for instance, we've read in, using our cin, we've read in int count, boom, and this will now go and create a number of memory units with whatever value in count is. Now let's say assume int count had a value of 3 as an example. What's going to happen is it will go and create 3 blocks in memory. Each of the blocks has an integer size, and our pointer now points to that location, and our pointer in fact has the value of the first block stored in it, which is F8. And I'm going to make it yellow to show that we have now initialized it. Okay, so this is how we declare it. And here we've now allocated memory to it, but there's still no values in there. Okay, that's one thing which you have to understand. These boxes are filled with whatever junk. I think there was a, make sure. No, there wasn't a question. Please, sir, I want to join Discord. Okay, that's a bit weird. Please send us an email, but you can also use the link on Discord, on Eve. So please feel free to send us a link on Eve. Okay, there's a question. What ID, what is F8? F8 is an address. Can you see in Excel? I'm just using the example of Excel here, but each memory location is an address. Watch yesterday's lecture, then you should know. Each memory location has an address. I'm using a representation here, easy with Excel, because this Excel's sheet or cell has an address of F8. That's why the value that's inside that cell is, I'm using this example as F8. Okay, hopefully that answers that question. Now this allocates our memory. Yesterday we also said that as soon as you allocate memory, and I made an example where I can potentially I can actually go and run this command over and over. And every time I run it, it will allocate 3 more, and another 3, and another 3, and another 3. And eventually that last 3, it will point there. And all of this memory is wasted because I will never actually use this memory. So one thing which you always have to do is after you've allocated memory for any kind of pointer type, whether it's a normal pointer, whether it's a one-dimensional dynamic array or a two-dimensional dynamic array, you have to have the ability to deallocate that as well. Now, how do we deallocate it? Well, that's very simple. We use the delete command. So yesterday, I said if you want to just delete the actual pointer, what you did was you did this. But because we don't want to just deallocate the one block there, you actually have to use a little open and close square bracket. That tells it, go and delete all the memory that was allocated with that new command. Luckily for us, we don't have to again specify the amount that we want to deallocate. That is not necessary. You just say delete, boom, 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 and all of the memory that was now allocated to these 3 is then removed. So effectively, after I run that, boom, you see the boxes is now gone. But our pointer still points in that unallocated memory. So one thing which is really good programming behavior is once you've deleted, you also have to set the pointer value that's inside this little yellow box to be null. Now in C++ 11 and up, you can use the word null pointer. And that basically will delete that value in there, and then this thing basically points to the null memory location. Okay, there's a question. Let's see. When we use the new command, does the value of the pointer change? Yes, it does. So effectively, as soon as you use the new command, the value gets populated in that pointer variable to point to the address of the new, I think they call it a temporary variable that gets created. Okay, how is it only referring to F8 when the array is size 3, sir? Okay, well, F8 is an address. That's one thing which you have to understand. So inside the pointer variable, it's got nothing to do with the size of the array. That's not how we work with dynamic arrays. And that's not where we keep track of these things. We as programmers have to keep track of the size of the array. That's why you will see when we go through the tutorial, have a look at the tutorial that I did on Tuesday. You'll see I keep on referring to the size of the array. Without the size of the array being stored somewhere in a variable, there's no way for me to know what that size is because it's not stored as part of the data structure at all. So the data structure, because it's just a pointer, just stores the address. Thank you, Mr. Sehu, for asking that question. Mr. Scorchas asked, so how do you implement the delete command in code? Exactly like I typed it there. Okay. If we are not using C++11, what would we use instead of null pointer? If you're not using C++11, you will use the word null, which is this. It's a, I think it's a C++ const variable or value. Okay, so if you don't use C++11, you will just use null. That's also a good question. Thank you for that. Next. There was another question. Sorry, just give me a sec. Let me get there. We will still use tables in C++. I'm not sure what you mean about tables. We don't use tables. A table is just a two-dimensional array. So we're going to definitely use two-dimensional arrays. Yes, definitely, absolutely. Okay, so now you've seen how we declare and allocate memory. How do I, so let's just get back to the picture that we had there. So this would allocate the memory. And we had a value inside our little box here. That value obviously was the address of the first item, F8. And now, once we've allocated the memory, because there's stuff in here, very good programming practice is to also initialize the values that's in there. So how do we initialize the values that's in there? Well, we do that using a for loop. So let's say we build a little for loop. While n is 0, while n initialize n, while n is less, n is equal to 0, while n is less than int count, then increment the value after each iteration. And okay, now it's going to be a bit strange. I'm not sure it's going to indent it nicely. But the way that we access a value in there now is through our normal array characters that we have, which is the square brackets. So we say this is, let's say, equal to 0. And this will now be repeated for the number of values that's in int count. So if its int count is 3, it will repeat 3 times with the value of 0, which means it's going to put a 0 in that address, 0 in that box, and 0 in that box. Hopefully now you can also see the significance again of the indexes and why we start at 0, because effectively what it means is it says go to the address that your pointer is pointing to which is F8, and add the offset of, what is our first one? 0. So F8 plus 0 is 0. F8 plus 1 is, in this example of me using Excel, it's GH, which is this location. F8 plus 2 in the last iteration will then point to this last box. Okay, and that's how you initialize your variables. And I'm going to demonstrate how we're going to do this. And then obviously after we've done everything and we don't want to use our variables anymore or our array anymore, we have to delete it, which is that, sorry, array numbers, and then array numbers is null pointer. Quickly to these questions again. Not necessary for us to, okay. Oh yeah, it's all coming together, great. It is not necessary for us to dereference the array before allocating 0. No, in fact, what happens, that's a very good question. Remember we said that with a pointer, before you can actually give it a value, you have to dereference it using that little star. So you have to do something like star array nums and give it a value. Technically, you can do that. You don't have to use the square bracket syntax. So if I do that, then it's going to put the value of 0 into the first box that array nums actually points to. And you can also, this gets a little bit complicated, but you can effectively say dereference array nums, and I think it's something to do with plus the size of an integer. I can't remember the exact syntax, and also make that a 0. But it's just to actually help us with dereferencing, you use the square brackets. Okay, so that's hope that made that's made C++ a lot simpler than, for instance, the C languages, that we actually dereference our arrays using the square brackets instead of the star in front of the thingy. Okay, hopefully you've seen how this now gets implemented. Let's do this now in code. So by the by, for those that are watching this recording at a later stage, I'm going to just show you the code that's on the screen so that you can put it in the later viewing register. Right, one day, there we go. That is the code for the late viewing register. And then let's get back to the coding. Mr. Korchas or Mrs. Korchas asked, are we also going to be tested on dynamic 2D arrays? Yes. In semester test 2, you must use dynamic 2D arrays for you to be able to get a good mark. Okay, because you'll see that a lot of the pracs says that the size of the world is provided through command line arguments and all la 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 la. So yes, everything will be dynamic arrays from this point onwards. That's why the prac that's going to be due end of next week will make use of dynamic arrays, 1D arrays. We're not going to focus on 2D arrays yet. Right, let's share. Share. Let's just share my whole screen. I think that's going to be easier. Okay, I think it should be on your screen now. Yep, it looks like it. Perfect. So we had this example where we don't know how many students we had. So let's go and declare our dynamic 2D array. Now, one of the things that you've learned, hopefully, when we work with static arrays is the use of a type definition. And we can still use a type definition here. In fact, if we do this, star, and I say type 1D array, then I can rather use this in my code to declare a one-dimensional array instead of having to remember to do an int star and all of these things. And whenever I use my functions, I can use this type. So I'm basically using this alias to help me declare a one-dimensional array. So let's go and do this. I'm going to say type 1D array, and I'm going to say this is, I'm going to have to give it a different, so let's say array students or whatever, and that's it. As soon as you do that, remember what happens? That first little block gets created. But what did I say with that's inside this block? That little pointer points anywhere in the memory at this point in time. We don't know where it is yet. So this little pointer is basically pointing anywhere. Okay, maybe there. We don't know. In fact, there's no value in there because all it did was it created the block, and we're going to have to now let it point somewhere. So how do we get it to point somewhere? Now we do this by using the new keyword. So we say array students equal to new. What must it point to? What is the things that it should point to? Should it point to type 1D array? No, we're not going to create a number of these one-dimensional arrays. It should point to a number of integers. How many of them? Well, let's put that in there and we say int count of them. Whenever we program, guys, get used to this. Compile often. Don't go and create lots of code and then you're starting to compile and then realize there's errors. 3-4 lines of code, compile. 3-4 lines of code, compile. Do that. Then you will successfully program. Get it in your head. All right, next. So now as soon as we've done this, these little boxes are now created. Int count of them. I don't know how many because it depends on when the user runs it. Now I have to, what is inside those boxes? Well, we don't know what is in there. So let's go and initialize the values in there. So this is initialize the 1D array values. For that, I'm going to create a little loop while n is less than int count, n plus plus. And then I'm just going to say array students n, and I'm going to initialize it initially just to a bunch of zeros. That's all I'm going to do. This will now add the value 0 into each of these little boxes. Let's again build, make sure no errors, mistakes. Doesn't look like there was any errors. Let's quickly see there was a few questions. I'm not too sure how heap memory works at this point, but because the array can technically have infinite values, does this mean that the moment we use the new keyword, the pointer points to the top of the heap? That's an interesting question. The heaps grows, well, the stack grows from the top to the bottom. The heap grows from the bottom to the top. So there's a special area inside the memory that these two little places or things actually grow into. So they're not infinite, they're actually fixed in their size, and that's what's going to happen if you don't, for instance, delete. Meaning if you just keep on adding new, it keeps on adding new things onto the heap. Eventually, that heap will fill up. And as soon as that heap fills up, the operating system will then kick in and it will stop the application from trying to allocate more memory for that variables. So basically, the heap grows upwards, meaning it's the last section, basically. So it's not at the top of the, well, it's the last memory address on the heap that it gets used, and then you add more. Interesting is that the stack memory grows downwards. So basically, we start with the high address value, and then it goes lower and lower and lower the more we add stuff on the stack. But guys, that's not too important. Line 13, what does it do? Let's have a look quickly. Line 13. Okay, this was just an example of a one-dimensional static array. That's how we declared a one-dimensional static array. And so as you can see, this was how we used a 1D array, and this is how we use a a static array, and this is how we use a dynamic array. Now let's have a look and see what's the code when we delete it. So when we delete, we say delete, to-doom, visit array of students, and then array students is null pointer. Hold, and it's done. Okay, so here we allocated memory. Up here declared the pointer. Here we allocated, here we initialized. And here we deallocated the memory. So those are the 4 things that you are always going to have to do when we work with dynamic arrays. You are going to declare, you are going to allocate, you are going to initialize, and you are going to deallocate. Now, hopefully, if you're a bit of an astute student, you would see that I did all of this now in the main function. But guess what? In the real programming, when we do this, we typically put these things into separate functions. Now let me demonstrate how we typically would do this in a function environment. So I'm going to create a function here that will do the initialization for me. Now, one thing which is really nice with dynamic arrays, it is fully returnable by functions. So that basically means I can create a function that can return a one-dimensional array. Okay, remember, I can create functions that does this, so get int, blah, 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 and then this thing will return an integer for me. I can create a function that will return a one-dimensional array, and I will call it init, let's say, array, and I need to understand the number of variables for it to be fully initialized, well, allocated and initialized. So normally we create one function that does both the allocation and initialization, well, initial initialization, and we don't typically have separate ones because, I mean, to allocate is just one line of code. That's a bit, yeah, so we don't want to just create a function to do just one line of code of work. So let's see how we're going to do this using using a function. So the first thing is I declare a variable, and I say it's going to be an array of numbers, and eventually I'm going to have to return my array of numbers. Remember, as soon as I do that, I created that little block. Let's go back to Excel. Remember, it just creates that little block, and that's it. Now I have to, so this, let me just comment this declares the pointer. Now we have to allocate the memory, and the way that we allocate the memory is we say array nums is new integer size of int count. Okay, as soon as we do that, these little boxes get created, and now I'm going to initialize to 0, so 4 int n. In fact, let's just do that. I'm going to copy and paste this code and just change the variable name. Boom. There we go. Now I've got a function that will do everything for me. Because I've got a function that will do that for me, I also need a function that will delete the array. So let's go and create such an array, a function rather, delete, say array, and I'm going to take in as a parameter the actual array. So it is a type 1D array, and let's say array of numbers. Now that is not correct yet. I want to explain to you why this is problematic. Just keep bearing with me for now. I'm going to try and explain it just now, but effectively in the code it's the same. So delete array numbers, and then array nums is the null pointer, just to make sure that it's not dangling. Okay, now let's quickly just call this initialization. So I'm going to get rid of that, and I'm going to say array student. In fact, type 1D array students is init array int count. But init array will run, it will pass int count into it. There's int count. Init array itself will declare such an array in memory, or well, it will declare such a pointer, and we will allocate the memory for it. We will allocate the we will initialize its values, and then we will take that value, this little box that was created, and we will say this little box belongs to this variable. So this variable that I've just created actually now uses that box that I've created inside this function because it was returned by this function. And then once I've used it in all of my code, I can delete it, delete array students. Okay, I'm going to answer the questions just now. I just want to quickly talk about this delete first. Why is this delete wrong? why is this not correct, this parameter? Now, this parameter, what it does is, and what it means is, it is passed by value. Now, if you look at this spreadsheet of mine, let's assume that this is what array students is. This little box is what array students is, belongs to array students. So I'm going to get rid of all of this, and I'm just going to say this belongs to array students. Okay, so that basically is that box. So if I open that box, that is the label on that box. Whenever I call the delete function, that little box, a copy of that box gets made. Remember, because that's what a parameter, when you use the ampersand, it actually makes a copy of that value in there. So it basically will make a copy. It will create a new box. Yeah, I'm going to start my class in just a minute, in a few minutes. And it's going to put the value of F8 in there. So basically, they point to the same location. So this is inside my delete functions. Inside my delete function. That variable called, what did I call it? Array nums, ARR nums. That box actually is called array nums. It also points, let me get a little arrow. It also points to that location. And when I say delete, what's going to happen? Where's my code? When I run that, it will go ahead and it will delete these little boxes, which is perfectly correct. So basically, it takes all of these boxes and it allocates it back to the operating system. But as soon as I run this line of code, array nums is equal null pointer, which box does it actually change? If I go back to Excel, it is this white box, and this white box then points to the null pointer. So the original calling function, this yellow box, is still not the same. But I can fix the situation if I pass it by reference. As soon as I do that, I say, hey, hold on, array nums, you are created. So array nums gets created, but you don't have your own little box. In fact, you will make use, maybe that's a better way to visualize it like this. You will make use of that box there. That is what pass by reference effectively means. So no new box gets created if you pass by reference. It uses the original box. That means if I do that delete, it will delete the value that's in there, and this little pointer will move up. Obviously, as soon as the function finishes, array nums gets deleted, and obviously that also gets done. That's why you have to, when you use a delete function like this to deallocate memory, you must always pass the value or the parameter by reference. Okay, now I can go and look at the questions. Okay, Mr. Rampela, when we work with dynamic arrays, we don't create the header file and the implementation file. Why not? Of course we can. I just didn't create libraries. Don't get confused with headers and function, and it's a different thing. Header files and implementation files are what we call libraries, and you can put code inside libraries, which means that yes, you can use dynamic arrays inside libraries. In fact, that's how we normally use it. This is just a lecture. I'm not going to create a whole library just to demonstrate the principles of it. Okay, so yes, you can use dynamic arrays in implementation files in libraries. So kind of unrelated question, does CodeBlocks have keys to align your code properly? Like I know NetBeans, yes, there is. I'm not sure if it's got a key, but it's got this little tool. I think it's a plugin. And where is it now? A source code formatter, A-style. Point. If you do that, it actually does the alignment for you. Okay, so that's one way that you can do it. Okay, that was a quick answer. Next. Will it still be okay if we don't create a function to do our initial steps? Okay, Mr. Sirku, that's an interesting question. The thing about the reason why we create functions, remember, is separation of functionality. It is also very good to create functions that focuses on one thing and does one thing correctly. Now, when we do an initialization function like I just described or showed you now, we typically do that because to troubleshoot it, we only have to focus on that one function. And in certain problems, we will create multiple arrays and not just one. And that's why we want functions. So as a rule of thumb, don't create functions with too long pieces of code. All right. As soon as you get code that becomes too long, then start breaking up that code into separate functions. It makes the troubleshooting of that code a lot easier, even though it may not be copied or duplicated somewhere in your programs. It helps you in focusing to just focus on solving a specific problem or not. Okay, the past one. Okay, the past one. Just curious, the past one. Okay, not sure. Why do we delete array students and not array numbers? Array numbers gets no memory gets allocated with array numbers. Okay, all right. So maybe that's. I think the question is probably more related here. I've got 4 more minutes. So here I've used and I've declared array numbers. Okay, and it returns array numbers. Let's have a look and see what happens specifically inside this function. So initially, when I call this function, I declare a variable. In fact, it's here. I declare a variable called ARR student. So let's go and do that. So there's array ARR students. And can you see that that variable doesn't belong anywhere? There's no value to it, etc. Then when I run the function of init array, it actually creates a second function, a second variable called ARR nums. So let's go and put that in Excel somewhere. ARR nums. It goes and creates that. And then it allocates memory to it. So we can decide where we want this thing. So let's assume this is the box. Let's just get rid of this quickly. And I want to get rid of that as well. Okay, so basically created this box. And immediately after it created, I reused new, and it created these 3 boxes. And it created the pointer to point to that location. Okay? And what was the value that was in here? It was F10 in this example, because this location here is F10. Can you see there's F and there's 10? Okay, but guess what? When I return this array doesn't get returned, only this value. So when I return this value, it goes to the box that we created for array students. So there's the box for array students, and it adds the value F10 in there, which means it basically points there. Now, one thing which you might not know, but whenever we create a variable inside a function, as soon as that function terminates, it deletes the variable as well. It doesn't delete the memory allocated to pointers, for instance, but the actual variable, meaning this original box, also gets deleted. So as soon as this function finishes, so as soon as immediately after this function return executes, boom, the computer basically takes all of this memory, which, so by the by, was created on the stack, and it goes and deletes all of that memory and gives it back to the operating system. All right, and that's why it's not necessary to go and delete the array after we've returned it, as an example. Okay, because we definitely don't want to delete the actual allocated memory. We still want to keep that, but we want to just delete the variable. So just to give you an example of what's happening here, these variables in this column was all created in a place where we call stack. This memory that I've demonstrated here is created on a place called the heap. And that's why it's also different in the computer and handled differently. Okay, ladies and gentlemen, that's it for today. When we're back next week, obviously there's no lectures on Monday and Tuesday because it's a long weekend and a public holiday. But please note, you are going to get a prac. The prac there's no physical prac lecture, meaning I'm not going to give the prac lecture, but there's a recording of the prac lecture, which I will publish tomorrow during the day on Eve. So please watch the prac lecture. so that you can understand the memo for P04 as well as what is required for P05. Use the tutorial information that we covered this week for you to be able to do the prac. Thank you very much, ladies and gentlemen. Have an excellent day. Where in the code does it tell the program type D as an array? It's in the type definition. Yeah, and for the upcoming practice, you use the command as well. That's correct. It's in the tutorials. We've covered that in the tutorial, so please have a look at that. Thank you very much, guys. Have a good day. I'm going to my next lecture now. Ciao, ciao. I have to stop recording.